Alrighty, so this is 6E, which is exponential graphs with translations. Please make sure to check the announcements on your paper. Make sure that you know when your first quiz is on this material. So right here I have all of our transformations listed out. We saw these transformations in semester 1 when we were talking about absolute value graphs. And so these transformations are all the same thing that we've done before. So there's, Pico says hello. So there's 3 variables that we're dealing with here. There's a, h, and k. So on an exponential function, the a is that initial amount that you guys learned about in 6b, okay? So that initial amount tells you about if you're going to have a reflection, which is where it flips upside down over the x-axis, if you're going to have a stretch, or if you're going to have a compression. Now the h is a number that's being added or subtracted from x, okay? Notice that that h is up there in the exponent. And the h feels backwards from what you feel like it should be because of the minus sign that's here. So if you see x minus a number, it's going to translate to the right, even though that's where the positive numbers live. And if it says x plus a number, that's going to be a translation left. Now the k behaves just like you think it would. Notice that the k is written at the same level as your base and as your a. And so if you have a subtraction of k, it's going to slide the graph down. And if you add k, it's going to slide the graph up. Now, exponential graphs are just really hard to read, so we're not going to worry ourselves about the a in this section, okay? We're going to mostly focus on h and k and just make sure that you know how it slides around the graph. All right, now I just want to talk about some of the key features real quick while we're looking at this here parent function. So these functions are made by multiplying and dividing by the same amount every single time. So on the parent function, as you're coming towards negative infinity, so as you're coming to the left here, you're dividing by, in this case, 2 over and over and over and over and over again. Now there's no way to divide by 2 a bunch of times until it reaches 0. Instead, you get numbers that get closer and closer and closer and closer to 0. And that's where you get that asymptote that we were talking about in 6b. So there is no x-intercept on this graph because it just gets closer and closer and closer to the x-axis there. Now, when we start doing translations, right, if I slide this graph down, it will have an x-intercept. So in general, unless there's been a vertical translation, there's not going to be an x-intercept. Now, all of these will have a y-intercept, all right? In this case, the parent function has a y-intercept here at 0, 1. And then in this case, we also have our asymptote, right? Which is that y equals 0. It's that line here. So let's go ahead and let's try some of these together. So this one just wants us to identify the transformations. So I'm comparing this equation to this one up here. So it says x minus 3, all right? So that's going to be an h value, right? And then we also have the plus 4. And this plus 4 is written on the same level as the 2 here, so that's going to make it a k. So I'm looking over here at these things. So x minus 3 is going to be a translation to the right. And this plus 4 for k is going to be a translation up. And when I write it, I'm making sure to include units and how far they're sliding, okay? So this was a translation right, 3 units. And this was a translation up, 4 units. All right, let's try that again. So here, the x plus 8 is our h, and this minus 6 that's here is our k. So if I look up above here, right, if it says x plus h, that's going to be a translation to the left. And if it says minus 6 for my k, that's a translation down. And I'm making sure to use all the words. So I'm translating left 8 units, and I'm translating down 6 units. And notice when this was a negative, I'm not saying it's down negative 6 units. The down is the negative part of that. Okay? We don't measure distances talking with negative numbers. That doesn't make sense. Like I wouldn't say that I walked negative 2 blocks down the road. All right, so looking at this one, right? I have an x minus 5. So my h there is the minus 5. And I have the minus 9 that's written at the same level down here. So that makes it a k. So when you have x minus a number, that means that you're translating right 5 units. And a negative k value is a translation down 9 units. Let's do it one more time. So x plus 4, and then I have the 12, which is a positive 12. So x plus 4, again, is an h. So I see right here, x plus h, that's a translation left. And this 12 for k is positive, which makes it a translation up. And make sure to use all the words for it, right? So translation left, and I'm saying by how many units? By 4 units. And a translation up by 12 units. It's also worth mentioning, a lot of times your book calls it a slide instead of a translation. That's fine as well, okay? If you choose to use the word slide, I have no problems with that. But make sure to say which direction it's going, like up, down, left, right, and by how far. Okay, now what we're doing here is we're going to use these graphs to help us to identify different translations that are happening, okay? So in this one, the light gray graph is the parent function. And then we've done a slide here. Now, the vertical slides are a lot easier to see than the horizontal slides. So what I tend to do is I look at the curve and I'm looking for an anchor point. So, I want to use red. So on this parent function, if I'm looking for the middle of this curve, the middle of the curve is about right here. If I'm looking at this blue function, the transformed function, the middle of the curve is here. And so I'm comparing from the first anchor point to the second anchor point how it moved. Now, the vertical ones you could actually see because these lines tend to flatten out. So I think that's pretty obvious that it moved down 2 units. But the other hard part is figuring out like how far left or right it moved. Like you could see up here that the blue one is to the left, but it could be really hard to tell how many units to the left unless you're checking out these here anchor points. So from this point to this point, it moved to the left by 3 units. All right, so that's going to change a few things, right? That's going to change our y-intercepts. Okay, so our y-intercept on our new graph is up here. So if I count that, that's it. 1, 2, 3, 4, 5, 6. And our asymptote, remember, is this horizontal line down here. It flattens out and gets closer and closer and closer to that line, but it never touches it. And so that's the asymptote y equals -2. Do you notice how y equals -2 matches what the k value would be here? That's the best way to tell. Let's do it again. I'm going to go out of order on this one, because why not? Do you guys see how this one flattens out right here? So this one's going to have an asymptote at y equals 1. And that tells you that there was this translation up by 1 unit. All right, now, is y-intercept kind of hard to see? We're going to be estimating that y-intercept. So I don't quite know what that is. I know it's a little bit bigger than 1, but it's less than 2. It doesn't look quite like 1.5, so I'm going to call that about 1.25. But that's an estimate, right? It's not perfectly on the crosshairs to help me out. And then the other thing we need to do is find out the horizontal translation. I know that it has slid to the right. I just don't know by how much. Okay, so what I'm doing is I'm looking for that nice anchor point, right? So like on the gray graph, the parent function, here's my anchor point. On the blue graph, here's my anchor point, because it's kind of the middle part of this curve. So it looks like when it slid up by 1, which we knew it happened here, it looks like it went to the right by 2. So that's a translation right 2 units. All right, we're almost there, friends. All right, so looking at this one down here, the asymptote down here is down by 3 units, so that's y equals -3, which means that it was translation down 3 units. All right, so I'm using that fact to help me with the anchor points, okay? So from here, I knew it went down 3 units, so I'm going until I hit that touch, or that middle point there. And it looks like from red dot to red dot, it translated to the right by 2 units. And a change in our y-intercept, this is so hard to see. Because see, it's not perfectly down at -3, but it is pretty dang close. Okay, so I'm going to call that -1, -2, and -2.5 would be like here. So it's not quite 2.5, it's a little bit further. So I'm going to call that about -2.75 and call that good. All right, one more time. All right, so I like to start with the asymptotes. I find like that's a lot easier. So on this one, it looks like the asymptote's at y equals 1. So that means there was a translation or a slide up by 1 unit. All right, the anchor points then, right? Because normally it's here. So if I go up by 1 unit, it looks like this graph was slid left by 2 units. And then we're estimating that y-intercept, which this one looks like it's nice and like on the graph really well. It looks like it's at 1, 2, 3, 4, 5. And so you got that nice clean y-intercept, which you don't always get while graphing. All right, so it says, what is the relationship between the k value and the horizontal asymptote? Well, the k value is the same number used in the horizontal asymptote. Right? So the equation is really y equals k. And it says, do exponential functions have vertical asymptotes? Like it's hard to tell sometimes, right? Like this one clearly flattens out, but this one, it doesn't actually end up flattening out. Okay, it just continues to creep very, very slowly to the side. So these ones do not have vertical asymptotes. And there we have it. Those are our translations.